probability is nothing more than probability using shapes. I'm going to give you an example, and I think you'll kind of catch on to what they're asking for here. If a 12-inch diameter target is hit, okay, write this down. If a 12-inch diameter target is hit, comma, what's the prob that the 4-inch bullseye, I think, is hit. 4-inch diameter bullseye is hit. Bullseye is hit. Question mark, question mark, question mark. And something I still need for you guys to focus a little bit on is because you come back and you ask me questions about stuff where you haven't even sketched out or drawn said problems. You really need to, I mean, it's something, you have to do it next year when you get to high school. You know, sometimes stuff comes to you after you kind of look at it pictorially rather than saying, I don't have any idea. So in other words, this, a 12-inch diameter target, well, here's your little target, it's 12 inches in diameter. You shoot at it, you hit it. The question asks you, what's the probability that when you hit that 12-inch circle, as you know with targets, there's another circle inside that that's only 4 inches. What is the probability that that 4-inch in diameter bullseye is hit? So when you shoot this thing, you're looking for, well, really the probability is just the same thing as what fraction is the area of the small one to the area of the big one. I mean, that's going to be your probability or whatever, because what area does that small one take up of the total area of the whole target? Okay, so it just means what is the area? What is the area of a circle? Pi times radius of the small over pi times radius of the big. And here, this should make you smile just a little bit here. Because pi is a constant. Okay, well let's fill in the blanks. What's the radius of the small one? What's the radius of the small one? The diameter is 4, the radius is 2. So it's pi times 2 over what's the radius of the big one? 6. Okay. Now this is what I said should make you smile. People get upset with pi because it's 3.14 and you have to do some work with that, blah, blah, blah. But if I have a pi on the top and a pi on the bottom, what's going to happen to the pi's? They're going to go away. So you don't even need to deal with the 3.14 because they're there. Now if this one didn't have a pi on top, then yes, I'd have to deal with it. But they both have pi's up there, so you could actually cross those off. You could really do the same things with the 2's and the 6's, because 2 goes into 2 once and into 6 3 times. 2 goes into 2 once and into 6 3 times. You could cross those off and just do this for your multiplication. 1 times 1 is 1. 3 times 3 is 9. The probability is 1/9 that if you hit the target, you're probably going to hit that middle section there. Now you got to remember, this probability deals a little bit with your skill as well. I mean, if you just kind of hit the target. That little circle takes up 1/9 of the area of the big circle, which makes sense because what's the scale factor? The little small, what's the scale factor? If the little one was 4 and the big one was 12, what's the scale factor? Go from 4 to 12, you multiply by 3. And if you square 3, guess what you get? 9 is the bottom there. Let's do another one because I can tell you're mesmerized. Here's one that has a circle but doesn't have something in it. What's the probability that an object lands in the circle also lands in the square? Here's from the book. They give you a circle that is 20 centimeters. And then inside this circle is a square that is 10 centimeters on the side. What's the probability that if something hits the circle, you're going to hit the square. So what's it going to be? It's going to be the area of the square over the area of the circle. And you fill in the formulas. The square is side times side, correct? Okay, the circle is pi times radius. Now this time you don't have a pi on top, so you can't cross it off. You're going to have to deal with it. It doesn't say leave it in terms of pi, so we're just going to, well, wait, does it? We're going to do it both ways. Leaving it in terms of pi and not in pi. Let's do it in pi first of all. How long's the side? Each side is 10, correct? So the top is 10 times 10. And the bottom is, what's the radius? 10. Oh, look at this. Isn't this going to be sweet? Do I have to do my multiplication there? What's going to happen here? Somebody? Anybody? This 10 and this 10 will cross off, right? This 10 and this 10 will cross off. So is my answer just pi? Michael says, why is it not just pi? Where's pi at? It's on the bottom. Anytime it's on the bottom, you gotta have something on the top. The probability is 1 out of pi, or leaving it out would be 1 over 3.14. Which is kind of what they're, or, because we don't put decimals in there, how could I change it so that it doesn't have a decimal in it? Does anybody know? If you have 1 over 3.14 with a decimal, and I don't want this decimal here, how would I have to change it? Grace? Well, you have to multiply it by a fraction that equals 1, which would be, how would I get this decimal to go over here? Multiply by 100. Multiply both top and bottom by 100, I get 100 over 314. Would be without the decimal point. You want to have one more, don't you? Yes. How about this one? Probability of this. You've got a big square with a triangle in the middle of it. Why isn't it changing to red? And the dimensions of this are 6, 8, 10, 10. Sorry, let me draw this a little better. Right triangle, 6, 8, 10, 10. What's the probability if you hit the square that you're going to hit the triangle? I'll give you a chance to figure that out. Probability is you shoot an arrow, when it hits the square, the probability it's going to land in here. We should be just about done. We should do it with respect to the cornhole game. Does anybody know what the rectangle of the cornhole? How big is the hole in the cornhole game? 4 inches? Probably 4 inches. 3 inches? It's probably 4 inches. Do we have probability, Gary? Don't tell me yet. We're still calculating. They are tabulating their numbers. Just the area of the triangle over the area of the square. Area of the triangle over the area of the square. Area of the triangle. Triangle over the area of the square. So it's 1/2 base times height over side times side. It's 1/2 of 8 times 10 over 10 times 10. If you do all the calculating there, you end up with, Gary Ronning, 6/25, I believe that is correct. If we do some cross canceling here, you could take out this 10. No, you can't do that. You can take out this 10 with this 10. Take half of 8, you get 4. What did I do, what? Oh, well that's, now you're making me do, so, alright, hold on a second. 1/2 of 8 times 6 over 10 times 10. Now let's do half first to get rid of this. Half of 8 is 4. So you end up with 24 over 100, but you could cross out some stuff. 2 goes into 4 twice, 2 goes into 10 5 times, 2 goes into 6 3 times, 2 goes into 10 5 times. You get 6 over 25. That's your probability. That's not that hard, is it? Probably not as interesting as